Hi, in this video we're going to be talking about the limit comparison test. So what we're going to do is we start with two series, AN and the sum of BN. And we make the condition that one of them is greater than 0 strictly, and the other can be greater than or equal to 0. It doesn't really matter what the other one really is. And we're going to define C. Now, we're going to define C to be equal to the limit as n goes to infinity of an over bn. And for our limit comparison test, we have that if c is positive and finite, remember positive means greater than 0, and finite, which means, it's less than infinity, then both series converge or diverge. So they converge or they both diverge. Okay. So that's what the limit comparison test is. Let's just go ahead and put that in the screen. And now let's look at a quick example of one. So we're going to look at one that we already looked at in the last video with the direct comparison test. So we're going to look at the series from, say, 0 to infinity of 1, or it's going to be n over n squared minus cosine of n. Okay, and when we do our limit comparison, we just kind of take the limit of this guy and see what it turns into, or if there's something simpler that it approaches. So we saw that as n goes towards infinity, what we essentially end up getting is the sum from n equals something big, to infinity of 1 over n. So that's a good place to start and compare it to things. So let's go ahead and use the limit comparison on this and see if we can actually get something here. So we'll take the limit of n as it goes to infinity of an. It doesn't really matter which one we pick. So we can do n over n squared minus cosine of n all over 1 over n. Okay, and when we do this, this is the same thing as the limit as n goes to infinity of n squared over n squared minus cosine of n. And we can solve this in several different ways. We can use L'Hopital's rule, or we can divide everything by n squared. So we'll just do that way first. So 1 over n squared. We'll take this whole thing and multiply this by 1 over n squared. And what we end up getting is the limit as n goes to infinity of 1 over 1 minus cosine squared of n over n squared. Now, as we go to infinity, this cosine squared is bounded, right? So this is bounded, and the n squared, it approaches infinity, right? So that tells us that this whole thing goes to 0. So the limit after we evaluate it is actually just 1. So remember, c is equal to this limit. So c is equal to 1. It's positive, yes, and it's finite, yes. So that tells us that the sum of n over n squared minus cosine of n and the sum of 1 over n both converge or diverge. And this is great because we know what 1 over n does. This diverges, which tells us that this guy is also going to have to diverge by the limit comparison test. Limit comparison test. All right. So now let's look at another one. We could go and do 1 over 4 to the n minus n, or it was, I think, 4 to the n plus n. But let's look at a different one and look at how that compares. So let's look instead at the sum of 4n squared plus n over the cube root of n to the 7th plus n cubed. And here we'll say n goes from 2 to infinity. Right, so let's just kind of take the limit, see what happens here. Just do some holistic analysis. So we know that 4n squared plus n, as n gets really big, the n squared overpowers the n. So we can just put this as 4n squared on top. And then the same thing with the bottom. The n to the 7th is going to overpower the n cubed. So it's going to be the cube root of n to the 7th or n to the 7 thirds. So we can simplify this a little bit. We'll make this 4 n to the 2 thirds or 2 minus 7 thirds. So that's going to be 6 minus 7 thirds or n to the negative 1 third. And we can rewrite this as 4 over n to the 1 third. And we can factor that out if you look at the series. So 4 over n to the 1 third. We can pull that 4 out, and this is just the sum of 1 over n to the 1 third. And now we can just use the p-series test, right? We use the p-series test. 1 third is less than 1, so it's going to diverge. So a small correction on my, I think it was the last video or the video before. I said we can't do approximations because 1 over n diverges, but 0.999999 forever, like for a finite big amount, diverge or converges, but that's not true. It would be like 1.0000, bunch of zeros, and then a 1 is going to be the one that converges. So remember, the p-series says that if p is less than 1, it diverges, and if p is greater than 1, it converges. So here our p is 1 third, so it's going to diverge. Now that's not so clear by looking at this guy, that it diverges. But what we can do is we can do our limit comparison test. So we're going to let c equal the limit as n goes to infinity, and we're going to compare this guy to this guy. So we can even compare it to 1 over n to the 1 third, which I think is probably a better way to do this. Because 4 is just a constant. If it converges, 4 times the number is just a number. So we'll have 4n squared plus n over the cube root of n to the 7 plus n cubed. And we're technically dividing it by n to the 1 third, 1 over n to the 1 third, but that's the same thing as multiplying it by the reciprocal. So we can say that's times n to the 1 third over 1. Now we can simplify this a little bit. We get 4n, that's 6 thirds plus 1 third, that's 7 thirds, plus n to the 4/3 over the cube root, but we can actually say that's n to the 7th plus n cubed to the 1/3. And remember, we're still taking our limit here as n goes to infinity. So these are equal. Now, as we approach infinity, what we have is we have infinity over infinity. So we can use L'Hopital's rule, or what we can do is we can divide everything by something they have in common. So our biggest exponent here is 7/3. So let's go ahead and divide everything by n to the 7/3. So 1 over n to the 7/3 over 1 over n to the 7/3. And we're going to still take the limit as n goes to infinity of 4n to the 7/3 plus n to the 4/3. And that's all going to be over n to the 7th plus n cubed all to the 1/3. Now when we do the top, that's pretty easy. We get the limit still n goes to infinity. 4n to the 7/3 over n to the 7/3 is just going to be 4. So we have 4, and then n to the 4/3 over 7/3. So that's 4 minus 7. So that's -3 over 3. So that's 4 plus 1 over n. Over, we can bring that 7/3 inside the cube root, and it just becomes n to the 7. So we have, on the inside, we have 1 plus 3 minus 7. That's 1 over n to the 4th to the 1/3. Okay. And now we can take our limit as we go to infinity. So taking this limit, we get 4 plus 0 as n goes to infinity, 1 over n goes to 0. Remember that we're taking the limit of the sequence now and not the limit of the series. Otherwise, it would diverge. But in this case, it's just the limit of a sequence and not the limit of a series. So it's going to go to 0. And then in the denominator, we have 1 plus 0, again, to the 1/3. And that's going to be 4 over 1, or just 4. Now, is it positive? Yes. Is it finite? Yes. So both either converge or diverge. And we know that 1 over n to the 1/3 diverges by the p-series test. And so that tells us that the sum, well, it's the sum of 1 over n cubed. So that tells us that the sum of 4n squared plus n over the cube root of n to the 7th plus n cubed also diverges. Right, so that is the nitty-gritty of the limit comparison test. If you have any questions, comments, or concerns, leave them in the comments below. And as always, thank you for watching.